Elon Musk, James Webb, and SpaceX will prove and find alien life in 2022. Elon Musk and his ideas are just as dramatic as my scores in any exam. Musk aspires to colonize Mars. He wants to create life on the red planet. But what if we find some signs of extraterrestrial life before his venture? But the question comes, who will do this job? Well, NASA has expected this job, and according to it, they have fired off the James Webb Space Telescope, JSWT, that is said to learn more about the universe and is going to find signs of alien life. So are you excited to know more about the JSWT? Then stay tuned in the video. Welcome to Elon Musk Newest. Don't forget to subscribe to our channel and press the bell icon to never miss an update on the new things we bring for you regarding the tech magnate Elon Musk and his wild endeavors. That being said, let's begin. In December, NASA launched the most influential telescope ever into space. The James Webb Space Telescope will be able to study planets outside our solar system with exceptional details, including checking to see if their atmospheres give any indication that a planet is home to life as we know it. The James Webb Space Telescope, JSWT, is the largest and most powerful space observatory ever built, and many space viewers say that the observatory is set to make a tremendous impact on the probe for alien life. However, the search for life beyond Earth isn't easy. Of course, and this telescope won't be able to offer up rock-solid evidence that aliens are out there. But some researchers say it's feasible that this telescope could at least find hints of life on Earth-sized planets that have so far evaded near scrutiny. Formed by the partnership between NASA, the European Space Agency, and Canadian Space Agency, the long-delayed $10 billion telescope pledges to revolutionize our knowledge of the universe by enabling scientists to peer further into space than ever before and unlock the secrets of the very first stars and galaxies. The observatory is said to be the legatee to the pioneering Hubble Space Telescope and will also explore our solar system in outstanding detail by shedding light on the paradoxes of dark matter and much more. The James Webb Telescope is heir to the Hubble Space Telescope, but it is more positive and productive because of the size of its mirror, the range of light it can detect, and its location. These characteristics will stimulate Webb to study the planets in our solar system and other planetary systems in distinctive detail. Moreover, the scientific instrument developed by Doyon's team is designed to examine many types of celestial bodies, including the atmospheric composition of distant exoplanets. What we're looking for, our holy grail, is biosignatures, that is, signs of extraterrestrial life, explained IREX coordinator Nathalie Ouellette, an astrophysicist who does communications for the James Webb. She urged to add that we shouldn't imagine these signs of life the way they are portrayed in science fiction films. We're talking about finding signs of biological activity or the signature of certain molecules that we have identified as essential to life, such as oxygen, water vapor, carbon dioxide, methane, and ozone. Based on the presence of such molecules, particularly in certain combinations, we may be able to determine that conditions are conducive to the development of life when we explore an exoplanet using the telescope. There are several modes of observing and deciphering the properties of alien worlds beyond our solar system. It's pretty rare for a telescope to view far worlds the way we see planets in our solar system, simply from the reflection of our sun's light. This is why the transit method has proven the most potent so far. The transit method is a norm of detecting and studying the properties of a planet via the dip in the brightness of its host star as the planet passes between it and us, like a tiny solar eclipse. But when the James Webb Space Telescope, JSWT, goes live, it will modify exoplanet studies, possibly offering the first chance scientists ever had to search for biosignatures in the atmospheres of alien worlds via transmission spectroscopy. Webb will have a tremendous impact on the search for life beyond Earth, because it will be able to study in unprecedented detail the atmospheres of thousands of extrasolar planets floating around the galaxy. This is a game-changer for the field. Claudia Mariston, a professor of astrophysics with the Institute of Cosmology and Gravitation at the University of Portsmouth in the UK, told the Newsweek. Although searching for traces for life wasn't part of the original task assigned over 3 decades ago, when the James Webb Space Telescope, named after a former NASA administrator, was first designed. Way back then, no one had found out any of the planets orbiting distant stars, and what scientists mainly craved was a telescope that could capture light from the first galaxies in the universe. Building this $10 billion instrument proved so complex and time-consuming. However, that in the meantime, a whole new scientific field has sprung up. That's the study of so-called exoplanets, planets beyond our solar system. The new generation of astronomers who work in this field is excited to take benefit of this telescope's power. I think the earliest discussions about James Webb were happening in the 1990s when I was in elementary school, says Laura Kriedberg, an astronomer at the Max Planck Institute for Astronomy in Germany who studies planets beyond our solar system. She notes that the first such planet around a sun-like star was found in 1995. Since then, scientists have discovered thousands of planets. Now, 25 years after the first planet was discovered around another star, we know that pretty much every star, on average, has at least one planet, says Kreidberg. She also said that JWST will provide a first look at the atmospheres of rocky exoplanets. We know that rocky planets are extremely common in the galaxy. There are tens of billions of them, but we still have many basic unanswered questions about these rocky exoplanets. Do they have atmosphere or not? If so, what are the primary molecules that make up their atmospheres? JWST will go a long way in answering these basic questions and set the stage for later searches for life. The launch of James Webb will revamp the proficiency to learn about these far-flung worlds. So far, it's been difficult to know what distant planets are really like, beyond some basic information like how massive they are and how far away they are from the star they orbit. That's because scientists usually don't see the planet themselves. Instead, researchers detect planets indirectly. For example, they can measure how a planet's gravity makes a star wobble, or watch as a star dims because a planet has passed in front of it and blocked some of the star's light. Inside the solar system, the telescope will also review, among other worlds, the atmosphere and surface of Titan, Europa, and Enceladus, the moons of Jupiter and Saturn that could potentially shelter some form of life. We have known about such planets and their presence for a long time, but we were not able to find more things about them. The Hubble, however, acknowledged us with a lot of information about these places, but still the JWST is going to outperform the Hubble, and that's no question. According to Kreidberg, Webb will offer revolutionary new capabilities compared to Hubble, due primarily to its much larger mirror, measuring 6.5 meters, 21.3 feet in diameter as opposed to 2.5 meters, 8.2 feet. This will allow it to collect significantly more data in a single snapshot. In addition, Webb is optimized to see the universe in infrared wavelengths. Hubble observes the universe largely in shorter ultraviolet and visible light wavelengths, but when it comes to studying planets, the information that we can obtain in those wavelengths is often curved by the effect of the clouds that surround them. Infrared telescopes can essentially peer into the parts of the universe that are hidden from other observatories. One fascinating planetary system that James Webb will study is about 40 light-years away. A small, cool star called TRAPPIST-1 is orbited by 7 Earth-sized planets, and 3 of them orbit in the zone where temperatures should be mild enough to have water in liquid form. If TRAPPIST-1e has a cloud/haze layer pressure of 10 millibars, 0.01 atmospheres, it could take up to 50 transits of TRAPPIST-1e in front of its host star, which could take JWST more than 200 hours of observation. Of course, it might be years before we know for sure that a planet orbiting a distant star has an atmosphere conducive to life as we know it. But with so many potential candidates, possibly millions in our galaxies, depending on conditions surrounding red dwarf stars, awaiting closer inspection with the James Webb Space Telescope, it's officially time to relinquish yourself with the hope that the search for life beyond Earth is reaching that critical point, where the big question mark about our solitariness in the universe turns into a positive outcry. Well, that's it from our side. We hope you enjoyed this video. Don't forget to leave a thumbs up. Make sure that you smash that subscribe button down below and click the bell icon to be the first to know when we upload a brand new video. Thank you for watching. We'll see you in the next one. Until then, peace.